An Introduction to Refractional Redshift, and How It Was Confused with Gravitational Redshift. Marius L. Vossile et Vossile Effect. In this paper I will show why refraction causes a shift in wavelength and a redshift, or a blue shift, which I cleverly named refractional redshift, and why it was not so cleverly confused with gravitational redshift. Refractional redshift is by far the most common and yet unknown type of redshift, and will remain so if this paper is not published. It is caused due to the fact that during refraction the speed of light changes, but the frequency remains constant. Since f equals v lambda, where lambda is the wavelength, it immediately follows that the wavelength changes too in order to preserve the frequency. This results in an increase of wavelength or a redshift when the speed of light increases, and in a decrease in wavelength or a blue shift when its speed decreases. The demonstration is quite simple, as we only need two simple equations in order to show that refraction causes a redshift or a blue shift. The first is the wave equation f equals v lambda, or lambda equals vf. And the second is the refraction equation v equals cn, where v is the speed of light in a medium, n is the index of refraction of the medium, and c is the speed of light in a vacuum. We insert the second into the first and we get lambda equals cnf. Since f is constant during refraction, and c is also constant, we see that when the index of refraction n increases, the speed and wavelength decrease, shifts to red, and when n decreases the speed and wavelength increase, shifts to blue. For two mediums with refractive index n1 and n2, wavelength is directly proportional with speed, 1-2 equals v1 v2. And inversely proportional with the index of refraction, 1-2 equals n2 n1. For example, during refraction from the Sun's atmosphere or heliosphere into space, the index of refraction decreases from n1 to n equals 1 and the speed of light increases from v to c, so the wavelength also increases and the light emitted by the Sun gets shifted to red. This would also explain why almost all galaxies appear redshifted, since they are made of stars which are all redshifted from refraction. Before reaching space there are, however, multiple refractions inside the Sun's atmosphere, which has many layers with different indexes of refraction, which regress as they approach space, i.e. the outer layers have a lower index than the inner layers, which are more dense. So the light gets redshifted multiple times in the Sun's atmosphere before it finally gets refracted into space and gets redshifted again. This would cause the spectral lines to be redshifted with each consecutive refraction. And those who claim that the gravitational whirl of the Sun is causing a shift in wavelength, or a gravitational shift, are simply ignoring the laws of refraction, which explains quite simply why light is redshifted near massive objects, which are all surrounded by dense atmospheres made from gases such as hydrogen and helium which affect the speed and wavelength of light. It is important to understand that light does not always travel at a fixed speed, unless its medium of propagation remains fixed. If not, it travels at different speeds, which varies with the index of refraction of the mediums, n equals cv. Therefore, when we observe a redshift, we must not assume that light has traveled at a fixed speed, or c in a vacuum, until it reached us, and associate the redshift with a drop in frequency, as scientists do, because they don't take variable speed of light from refraction into account, and use c as the standard value for the speed of light, instead of v equals cn. So by ignoring the mediums in which light traveled, they erroneously apply the formula f equals c lambda, instead of f equals v lambda equals cn. Thus, if lambda increases, to them a redshift can only mean that frequency decreased. When in most cases, when light is refracted through different mediums, the speed of light has changed, not its frequency, causing its wavelength to shift. That is, in my opinion, the main reason why scientists, including Einstein, failed to see that refraction causes a redshift, and confused gravitational redshift with refractional redshift. Because the so-called gravitational redshift experiment was not done in a vacuum, but in the Earth's atmosphere, in which a bag of helium was added to minimize scattering. More specifically, the gamma ray traveled through the helium bag, and then through air, as the metal target and the detector were placed outside the helium bag, as shown in the picture below. The gamma rays traveled through a mylar bag filled with helium to minimize scattering. Wikipedia. It doesn't take a genius to realize that the gamma ray was refracted from helium into air, which has a higher index of refraction than helium, causing its wavelength to decrease and shift to blue, or increase and shift to red, depending on the different setups of the experiment. In other setup they placed the emitter under the helium tube, and the detector above it, creating an air-to-helium refraction and a refractional redshift. The gamma ray was indeed shifted, but by refraction, and not by gravitation. Yet for Harvard University and the Nobel Academy this was a gravitational shift, just like Einstein predicted. Except Einstein did not predict that gravitational redshift occurs in the presence of helium, and nowhere in his proposed tests of general relativity does helium appear star. Why does it appear in this experiment, then? Because there simply was no gravitational shift in the absence of helium. So they blamed it on scattering from air, not on Einstein's theory being wrong, and thrown in a bag of helium to prove it right. But it simply does not follow how the use of helium leads to a gravitational shift, when it can be so easily proven that it leads to a refractional shift. Because the helium and air mediums in which the experiment was set obviously caused a refraction of the gamma ray and a change in its speed and wavelength. So what they observed was just a refractional redshift blue shift, and not a gravitational one. The only logical conclusion of that experiment is that refractional redshift exists and it was confused, deliberately or not, with gravitational redshift by the researchers. Their Nobel Prize should be cancelled and the scientific community should immediately revise all experiments which claim that confirmed general relativity. Because this experiment did not confirm general relativity at all, and in fact it infirmed it. Since the shift was caused by refraction, and not by gravitation. Given that helium is not gravity, and it does not appear in Einstein's theory of general relativity or in his proposed tests to confirm it, Pound and Rebka should have not used it in this gravitational experiment, unless they were really desperate. Indeed, they were so desperate to get the Nobel Prize, that they even drilled holes in the floors of their Harvard University, presumably to impress the Nobel jury. When they could have simply used the stairwell, as a gravitational well, of course. So adding a bag of helium to produce a redshift out of thin air, and helium refraction, was just another act of desperation. This experiment should have been performed ideally in a vacuum or, if not possible, in the same medium in order to avoid refraction and refractional shift. As it was, it did not prove anything other than refraction changes the wavelength, which was probably known at the time by some scientists, including some Harvard ones, but excluding the Nobel ones. And the Nobel Academy is ultimately responsible for reviewing, approving, and awarding Harvard's completely failed, or doctored, experiment. This gravitational redshift experiment is one of the 3 tests proposed by Einstein to confirm general relativity. He stated that if any of these tests fails, then his theory was wrong. Since I have proved without a doubt that one of these tests has failed, the conclusion is that general relativity is wrong. And that the standard cosmological model is wrong, since it is based on relativity and relativistic redshifts. So from now on, it should be called the standard cosmological model. References.